Hello, welcome to another coding session. Back with Bangalang. Super happy with the progress we made recently. We have flow control now, we have procedures. It feels like we have a lot in this language now, compared to just a few episodes ago. We have a lot. I think this POW function or procedure, I keep saying function. I want to say procedure because I feel like it's a little more correct. But this POW procedure, I feel like is the coolest example of our code so far. It's the first actually useful procedure, I think, that we have. It's like, you would find this in a standard library. It takes this number and it raises it to the power of this exponent. It can square or cube or go to the power of 4 or 5 or whatever, which is pretty cool. And it's a nice example of a procedure with multiple parameters as a return. We have a loop here. We don't have if-else, but further up in the file you can see some examples of me playing with if-else. So yeah, super happy. I'm really impressed that we managed to pump that stuff out in the last few episodes. And now I think it's time for types. I'm really keen to have a go at types now. And I think types is going to be a big deal. So we're going to break it up into some easily digestible chunks. And we're going to start with, I think, creating a new stage in our compiler. So I'm going to draw a bit of a, did I do that twice? No. I'm going to make us a new little diagram here, and I think I should have done this a while ago, actually. And we're going to visualize our compiler architecture. So let's make some circles as well, like that. So we start with our source code, which is a bang file, right? And then we feed that into the first stage of our compiler, which is tokenization. Actually, I think I would like to, I've been thinking about this for a little while. I'm just going to rename that file to tokenization. I feel like it's a bit more consistent with the other files. Just a little side quest. Okay, so then after we do tokenization, we end up with a token stream. Let me zoom in a bit here. We end up with a token stream, and the token stream gets fed into the next stage, which is parsing. And the parser produces an abstract syntax tree. So we have that visualized over here, actually. The abstract syntax tree that we're making now is probably a bit more complex than this. We made this a little while ago. And it's just kind of, I guess, an example of, to visualize, what it could look like. So yeah, this is the tree that we're creating when we parse. And then we move to the next stage, which is the generation. And that's where we finally create our assembly. So that's kind of our compiler. There's also, after that, we go, we assemble and then we link, but that's done by external tools. That's done by NASM and LD. So within the compiler itself, these are all the stages. And what I want to do now is add another stage. So let's bring this over here and pop another stage in here. And the output of that is actually going to still be the abstract syntax tree. But it's going to add to the abstract syntax tree. Let's move this a bit further away again. It's gotten a bit bigger. And this extra stage is type checking. Because at the moment in our generation step, we have like some checks and stuff. And I think I mentioned it before that it didn't feel quite right to have some of that sort of stuff going on in there. I feel like generation should just be focused on creating assembly. It shouldn't be worrying about other things. So since we have some checks in here already, the first thing I want to do is split them out, take the checks out of this and create this step from those checks. Okay. So yeah, we have generation. So I'm just going to copy that file and make a type checking file. And what are we going to do in here? Well, I think this procedure object will live in there. I don't think we need this here. I mean, let's see. And these built-in procedures, I think, also will be part of the type checking. We'll go like this so that all of our files are in order of the steps. And we do need another context for this stage, but it's going to be a bit of a different context. And it definitely won't need those indices or stack top. Let's see what else we need to do with this. But let's rename this actually. We're going to do a bunch of copy and replace, I think. So like type checking context. Like that. And anywhere when we have generate underscore, it's going to be type checking underscore. And then basically we're going to pull out anything that's related to generating assembly because that's not part of this step. So this is just creating a file and adding the initial assembly. There's a bunch of assembly here that we don't care about. We don't need the file name because we're not printing a file. And I think there's going to be a lot of functions that start with that. Start with a file as the first parameter. So we'll just take that out. And yeah, in the file declaration, we need to take that out. The procedure declaration. Okay. Stack top is not a thing. That's assembly, right? Yeah, that's printing a label. So we're just going to have to go through this file. So that's stack top. I think in type checking, we are going to need to keep track of our variables. Because we have the checks to determine whether we're defining a duplicate identifier or whether, in some cases, the identifier needs to be declared before we use it. So we need to keep track of the variables, but we don't need to keep track of their positions on the stack. Let's call it variable types because type can just be a string for now. Because we're going to need to keep track of types. I mean, right now we're not doing any actual type checking. But let's just try this. So we'll just put an empty string, and this is just to record that the variable exists right now. That'll do. We don't need this. This is assembly. And another thing we want to change is that I want to return a bool. And the bool is, I think I'll make it a named return. And that bool is like whenever we check something, we're going to determine whether that was okay. Like basically all of these are going to return bools to say whether the checking was successful or not. And if it was not, then we say okay equals false. So I guess we'll need to default to true. So the type checking is okay unless any of these resolve to false. Let's do the same down here, but I guess this is a procedure. So we'll name this procedure okay. Yeah, just like that. Okay. Yeah, and then we're going to do the same thing for basically every function, or every procedure is going to return a bool to say whether it was okay. And then we need, because we're using named returns in Odin, we need an empty return statement at the end. So here we say scope okay. I'll just copy this pattern here. I mean, we could have just said okay equals this in this case, but I think it's maybe a good idea to always do this pattern. So then if later I add something else in here, then it should be just fine. It should just still work. So let's grab this again and put it down here for type checking a statement. In this case, I think it's fine just to do this because we just have a switch. We don't need this assembly. So it can only ever do one of these things. And we'll put an empty return. Let's take this down further. So when we're doing an if index, all this stuff we don't need. This is printing assembly. This is also this else index we don't need. So let's take all this stuff out. That's assembly. This is all, I think this is just creating a variable for assembly. Yep. This is assembly. This is assembly. So we're left with these type check calls. This up here, I feel like I've established a pattern now. And the pattern is to do something like this. Yeah, like this. And then maybe we'll put that up there. And then we need to do our checks. Right? So we'll go scope okay. Expression okay. If not expression okay, then okay is false. And the same kind of thing in here. But I guess this is the else if. So we'll go else if expression okay. And also else if scope. Else if scope okay. And then we have another scope, which is just the else. That else scope, just check that that is okay. Yeah, that's it. It seems happy. These guys are just unhappy because I haven't implemented those procedures yet or changed them over. So for the for loop, we don't need to keep track of the index. We don't need to print any assembly. That's printing assembly. That's printing assembly. Give us an empty return, and now we just need to add our if statements to all these. So declaration OK. And this is expression OK. And down here is also expression OK. And this is scope OK. The flow of this procedure is a bit strange, I have to admit, the way that it goes through the for. I think maybe it's an artifact of the grammar for the for loop being a bit weird. At some stage we can probably improve that. Okay, so that's that one. Now we're onto the scope. This is maintaining indices, doing a label. This here is assembly, and I think this was just a variable we created for assembly. We still need to do this context business, I think. We just need to type check this statement. So let's say statement OK. We need to add here. What do we have? OK bool equals true. Cool. And an empty return. Getting there, getting through this. Get rid of that, get rid of that. It's all assembly stuff. So our first actual check. Here's our first actual check. But we don't have stack vars anymore. We have, what is it, variable types. So this is why we need to keep track of them for stuff like this. And not fail to generate. Let's just do another copy and replace. Let's actually failed to type check. And go variable types, and we're just going to put the empty string in because this is declaring a variable, so we just want to keep track of the fact that it exists. That's all we care about right now. Okay, this looks very similar, but now we're making sure that it does already exist. All this stuff I think does not matter. We just want to type check the expression. Oh, which we did not do up there. So let's add that. Actually, maybe I'll call that RHs this time. RHs OK. And I think this is exactly the same. And an empty return to keep Odin happy. All right, on to the next one. Let's get rid of this comment. This is all assembly, so we're just type checking an expression. At this time, we call it expression node, like so. Now we go to the type check expression, which cleared up a lot of errors because we were doing that a lot up here. And for this, whoa, okay, so this is all assembly. We can cut all that out. Also, this register number stuff is really to do with generation, right? Register number. Okay. So now let's do LHS. Okay. And the same with right-hand side. And up here, we'll do with the, well, I guess this one really is just, it's just the node, isn't it? I feel like this one we can just do this. Yeah, we're returning straight away. Okay, I think that's that one done. Move on to here. We don't need the register number anymore. So we can cut that out. This is our variable types. Okay. This is another one where I feel like it's, you know, we can just go OK equals because it's just a switch over a bunch of different options. So we can go like that, take out the register number and remove this assembly. What are we going to put there? I don't know. Also here, an identifier. Is there nothing we need to do for those? Like, oh, so, yeah, we've still got exit 1. We should actually say OK equals false. Like we need, if we're not putting OK equals false anywhere, it's never going to fail, is it? We don't want it, so we're not going to just crash. The idea is that we're not just going to crash when something goes wrong, because since we've succeeded to parse, it means that the program is well structured, which means that we can, because we have the tree structure, we can quite easily look through the whole tree, and even if we find an error, it doesn't mean we can't just continue and look for other errors. So we're going to try and find all the errors in the tree and then show all of them to the user. So we want to do OK equals false for this, and for this, and for this. Otherwise, it's just true. And here also, there's nothing to do. I do think, let me just have a quick check across here. Yeah, I think I'm just going to prefix this with bug, because the idea being that like this should never happen, right? If we've parsed correctly, we should not come across anything wrong here, right? And this is another switch, and I'm just wondering if this has got the same. Do we not have any error handling here? We're just assuming that it's all okay. I think we should put more error handling. Let me find this. Here we go. I think we should put a default case in here. Oh, the default case is to do an expression. That's why. Okay. That's why we don't need to error handle. Okay. So here we don't need a register number. We're type checking a call. And finally, all the errors above are gone, so that's really nice. Here's that same pattern that I talked about before. And here we have, we're getting our procedure information. So this will be OK equals false. And this is all assembly. And now we're type checking the expressions that we have for the parameters. So let's just make sure that we say OK equals false if any of them have issues. Okay, I think that's that one. So here, this is our variable types. We don't have these indices and we don't have the stack top. Did we use this in proc at all? We set it to true, but I don't think we actually use it. So let's cut that out. We did use the procedures, right? Yeah, we use it down here to make sure that the procedure exists. So I think that's it. I think that's... So this file is just doing all the checks that were in generation before. So now in the generation file, we don't need to do this anymore. This was determining the procedures in the file. We're just going to cut out anything in here that is a check because we've moved it to the type checking file. So let's just have a look through here. It's just printing assembly. I don't see any checks yet. Declaration, here's a check. We'll cut that out. Assignment has a check, cut that out. No checks in here. But again, I'm going to say that's a bug. That should never happen. Yeah, that should never happen. These are legitimate errors. These are legitimate checks. Yeah. This should never happen. This check we take care of in type checking. Okay. So I guess we don't need to do this procedure stuff anymore because that's in type checking. Yeah. And then down here, we don't have procedures in here anymore. But we do have this in proc, right? Oh yeah, because that determines what we do when we return. If we're not in a procedure, then we do an exit. Yeah. Okay, so I think we've extracted it out now. So now we just need to, like, if we run it now, it should succeed, but it doesn't actually do any checks. You know, if we say num5, so that should be an undeclared identifier. It's just like, it's fine. Everything's fine because we're not actually calling the type checking. So we want type check. Oh, okay. I think I did that wrong. I think it should be type check, not type checking. So let's change that to type check. I think that's better. Except for this. Make that type checking. So then when we go back to main, we do type check program. Sounds like more like a verb, you know? And then we just say type check OK. And if it's not OK, then we're going to exit. We're not going to go to generation because we didn't pass type checking. Just like that. I'm a bit curious if there's any imports that we had but we don't need anymore. Nope. Looks all good. So now if I run it, we get failed to type check primary undeclared identifier. Great. So I think we've extracted the type checking or any checks that we had. Now the next thing I want to do is I want to add type annotations. Okay, I think I already did, let's check. I think I already did, if I go to file types. So I use CLion, it's a JetBrains IDE, and I can make a custom file type and say what my keywords are. And I already have these keywords in here, yeah. Okay, so those are my types that I want to introduce type annotations to the language now. I don't think in this language they will actually, I don't think in this episode the type annotations will actually do anything yet, but I just want to introduce them and at least parse them. And then in the next episode, I think we're going to tackle the actual implementation of them. Because like I said, type checking and types is a decent task, so we can't really do it all in 1 hour. So we need to expand our grammar a bit to accept types now. So it's going to be declaration for sure when we declare. We can put a type, and that's going to be optional between the colon and the equals. It's similar to Odin, basically just stealing from Odin at this point. Yeah, so optionally you can put a type in here because maybe the type is inferred from the expression, so you don't always have to have a type in here. And then let's steal this colon type because in our procedure declaration, we're also going to need to do this. But in this case, the type is not optional. So we have identifier colon type. Let me scroll this across a bit. And then also here we have identifier colon type. And then the procedure also needs to return. Where is that? Here's the closing bracket. It needs to return a type. So we're going to put an arrow here. Looks like we need to put slashes. And then a type, like that. This is also a required one. So when you are declaring procedures, you have to put types for everything, the parameters and the return. Okay. Yeah, and we're going to use I32 and I64 for our types. So if I go I64, that's a 64-bit integer. And then, like I said, for the procedures, it's required. So we're going to have to go I64 to I64. That's the same. And this PAL, let's go like that. And then I'm also going to do, just so that we have the other type somewhere, I'm going to make a variant of this procedure which takes I32s. And we'll call the 32-bit version. Why not when we do that? Okay. So we've added the type annotations based on our grammar. Probably we would need to add a lot more. Like here, what type is 0? Is it 32-bit or 64-bit? It would need to be specified. So we should get some errors still. But I think we've done enough that we can just start. So for tokenization, we need to add, let's call it data type. A data type one, and also an arrow. Let's put that here. Those are the new tokens, data types and arrows. And data types, let's just add a new list here. I32, I64, similar to what we did with keywords. And then when we go down to where we're parsing our tokens, we can see this is when we do the minus. Now the arrow starts with a minus, so we're going to have to put like an if in here and say if, first of all, we're going to have to check that there is another character after the minus. And if there is it a greater than? Index plus 1. Is that a greater than symbol? If not, we'll just do what we did before. We'll just say that it's a minus token. But if there was an arrow there, then we create a token which is an arrow token. And because it was 2 characters, we plus equals 2 for both of those. So that should take care of our arrow. And now let's go down to where we were doing identifiers and keywords. So first we create an identifier, and then we check whether it was actually a keyword. And if we do, we override the type. Now I did find, actually, that there is this linear search. Because I do these manual searches through like arrays and slices and things quite often. And it turns out that I do not need to, because I can just do this. And then we can say, found keyword, like that. And if found keyword, then set the type to keyword. So linear search does actually return 2 values. The first one is the index where it was found within this array or slice or whatever. I think it's a slice, technically. Yeah, we call them slice functions. So that's the index, but we don't care about the index. So we use this underscore, which in Odin means, but just ignore this. And then it also returns a Boolean to say whether it was found. And we do care about that. So now what we're going to do is we're going to say otherwise, and we're going to do another check and see if it exists in the data types slice. And if it does, we'll set the type to data type. Okay. So now I think we can tokenize, but we should get some parsing errors. Yeah, because it found a data type when it was not expecting one. So let's go to parsing. And we want to parse a procedure and a declaration of what has changed. And it was between the colon and the equals. Am I right? No, not here. For a procedure, it is to do with the parameters. So it's actually here, and it's required. So here there needs to be a colon, and then there needs to be a data type, which I actually want to add to the node, like that. And because we're modifying parameter node here, we need to move this down. That's got me previously. Because this append is taking a copy of this node. It's putting a copy of it into the children. So if we take a copy before we've added the data type, then in children we don't see the data type. But data type does not exist yet on an AST node. So let's add that. We'll put it here. Probably later down the line, maybe instead of strings, we can have something better like an enum or something, but strings is fine for now. We actually need the value of it. Cool. So we probably need something similar also after the closing bracket. We have an arrow, and then I guess we just say that it's the data type of the procedure node. It's the return. I think that's fine. So I think that should work for parsing. We have colon data type and we have arrow data type. I believe that's what we added. And now if we go down to declaration, now this is where it's between the colon and the equals. But this time it's optional. So we say if peak token dot type is a data type, then we're dealing, oh, we need to move this down too. Need to be careful. Then we want the left-hand side data type to be the value of the data type token. Is that it? It's just an optional type. I think that's it. Okay, and we've got an error down here. What's this about? It's because we're creating a node, but we're not, because now it requires a data type. Can we just give it an empty data type, or is there? I mean, at the moment, we don't really know. I think at this point we don't know what type an identifier is. Let's just leave it like that for now. Maybe we can change this later, but I think that's fine. So now we've parsed it all. So it should probably work, right? Yeah. Okay. So in type checking, the little bit extra that I would like to add actually is that this procedure object, I think, should have all the type information, not just a parameter count, but it should know the types of the parameters. It should know its return type. And then when we do a call down here, we can grab the relevant procedure and then we can confirm, we can check like, do each of these expressions also resolve to that correct type or not? We won't actually implement those type checks now, but I think it's a nice preparation. We're kind of doing some groundwork here, so I think it's a nice preparation if we expand this object. So we'll say param data types, and it's a dynamic array of strings, and this will be a return data type, like so, and that has broken those. Because we're using a dynamic array, we can't do it in a literal like this. Because dynamic arrays do allocations, Odin by default does not allow you to, like, you couldn't just do, like this to represent, well, I guess it's a string now. You couldn't just do like this. Yeah, see, it says literals of dynamic types are disabled by default. So just to get around that, we'll just declare them in here and add them to the context, I think. I mean, add and +1 we'll probably eventually just get rid of because, I mean, why do we have them? I mean, now that we can declare our own procedures, if we really did want to have those as procedures, we could just create them as procedures. So let's say name equals add, and we can probably do the return data type. Sometimes the autocomplete is not great. Well, we said it's I64. Well, let's just say it's I64. Do I need to do like this? Okay, I need to do like that. That's probably why it didn't autocomplete. And then we want to append to the param data types and I64. In the case of add, there are 2 parameters. And then we want to add that procedure to our context. So that's add done. Now exit takes in a single parameter, doesn't have a return type. So I guess it's just that. And then +1 has a single parameter and a single return type. So that should be the built-in procedures done. And now when we add the procedures we've defined in our source code, we also need to, construct a proper object now. So let's start with an empty procedure. And I think we're going to need to loop through all the child nodes of the procedure. And the Odin has this handy syntax here where we can also grab the index, which is good for us because if the index is 0, we want to do something special. Because the first child is the name of the procedure. And the last node of a procedure, the last child of a procedure is actually the scope, it's the body of the procedure. So we want to ignore that. So this is just our way of saying, if it's not the last child. So it's not the first child, it's not the last child. That means it's a parameter. So then we can append to procedure.param data types the data type of that node, which is, during parsing, we set that, right? And we also set the data type of this node to be the return type. So, I guess we could put that here. Return data type equals, no, not that, it's this, node.data type. So that's created our procedure, and now we just need to add it to our context. Cool. So now we have procedures with type information. Nice. Okay. And now down here, we don't have built-in procedures anymore. And we want to actually have the procedure object. So I guess to prevent name conflicts, we'll do this. So we're looking for the procedure. This is checking the parameter count. I think actually we want to do that separately. Down here. So this loop is just finding if we have a procedure with the correct name. I'm not using that slice function here. I thought it was, oh no, tokenization is where I used it, right? Oh, why import slice like that? Interesting. I'm just picky about ordering, that's why I suddenly jump back there. Yeah, so we just found the procedure. I'm not using that linear search here because we have a bit more of a complex condition. I think there is a way to do it using one of those slice procedures, but I can't be bothered to figuring that out right now. So if we say that the name of the procedure is empty, because this is an empty procedure we initialized up here. So if we never called this, then the name should be empty. And that means that we couldn't find the procedure. And then here, I also want to do an extra check, basically. To check that we have the right number of parameters. So we can say like a wrong number of parameters. Now we have the param data types. So we'll just check the length of that to get the number of parameters. And those two should be equal. Maybe we can do one of these. Oh, we should maybe take that out and just use node. Yeah, because we no longer have this S in here, so we needed to take that out. So I think we can do one of our kind of expected found. So it expected this, and it found this, right? So that's an extra check. Now, and down here is, yeah, we would do some type checking soon. Wow, so now we get a bunch of errors. Wrong number of parameters, expected one, found one. You know, I think that's right. I think this needs to be a not equals. There we go. Whew, that scared me for a second there. We're getting near the end. I didn't want to have an error right at the end. I think we do have like a little bit more time. Maybe let's just check that. Like if I go pow 334, it should say wrong number of parameters. Yeah, nice. Expected 2, found 3. Cool. So now I feel like this new type checking file is quite good. We've taken all the type annotations through the tokenizer and the parser into the AST, and then we've even put them onto our procedure object. So I feel like we have a lot of type information now that we can use to type check. So that was really good. I think just as a little side quest at the end here, something I'd be interested to implement is to have comments, you know, raises num to the power of exp. And this does the same thing. And then maybe we can do multi-line as well. So let's add comments, hey? I think that's a nice little side quest. Invalid token. I don't think it really exists in the grammar, and it doesn't really represent a token. It's kind of a special case where it's just, we just ignore. If we come across a certain pattern, then we just start ignoring stuff. So if we come across a slash, similar to what we did with the minus, I guess, here, the else will just stay the same. It'll be a backslash token. But if we find another slash, then we're going to have a loop similar to what we have like in here. I don't know if we need it to be quite as complex as that one. We're never going to make a token in here. So while there is, while there is another token, another character, and that character is not a new line character, we keep incrementing the index. Do we need to do that, or is that just that we just increment these? You know, maybe we increment them here, and we're just saying this. So if we start with // well, I guess then we increment twice to go past both of those slashes. And then at the current, if the current index is still something, but it's not a new line, then we just keep moving past it. So I feel like that should work for the single line comment. Yeah, so now it's at 112, it's confused. So it got past here fine. And at 112, it's confused because we haven't done this yet. So in our tokenizer, we need an else if. That did not work well. Okay. And this is if we found a star. And if we found a star as the second character, again, we do this, but the end condition is different. So the end condition is, I'm going to say +1 because we need to check 2 characters. We need to check index and index +1. So there needs to be 2 characters still in the source file. The first one needs to be a star, and the second one needs to be a \. And I guess the unique thing about this is here when we found a new line, we just quit out. And the new line would have got dealt with by the next iteration of the loop. Here we need to consume these 2 when we find them. So we need to, but only if we did actually find them. So if we go found end, so what happens if you have an opening comment, multi-line comment, and it just never closes? Is that valid? I don't think that should be a problem. It's just like you're commenting out the end of the file. I think that's fine. So that's why we're going to have this flag here. But we can never set it to true in this loop. So the reason that this loop would end is because we don't have enough characters left, or we found //. So if we did have enough characters left, that means it came out of the loop because we found this. And then we can consume those 2. Yeah? Cool. And I guess if we run the output, it works. So maybe just to test it a little bit more, let's put it somewhere up here. Still seems like it passed okay. Yeah, nice. And now, just to finish this off, this is the last thing I want to do in this video. Nested multi-line comment. A lot of languages don't support this. Like if you had something like this, you would kind of need to escape these, which is really kind of annoying. Like if you already have a multi-line commented out code or something, you know, when you're debugging and you want to just like comment out a block of code to see whether it was the issue or not, then you might have a commented out block, and then you want to comment out a block that contains it. But it gets a little bit tricky because these need to be escaped, and IDEs don't always handle it very well. And I noticed when I was reading about Odin that it does support this. You can just have it like this. Now, right now, I think it's going to give an error. Invalid token. Yeah. So I think what we need to do is during our tokenization, during this loop here, we need to keep track of how many times do we see the opening pattern. So while we haven't found that, inside here, we kind of need to it does get a bit complex, doesn't it, now that I think about it? But have this case here where we look, so we haven't found that. We do know that there's two. No, we don't know that there's two more. So we recheck that there are two more. And if those two are slash star again, so that's the opening of a new thing. Then we'll have this nested count. That we increment. Yeah, we'll increment the nested count, and then we'll consume them both. And then we'll continue. And then whenever we come across this closing pattern, yeah, so we might need to bring this in as well. So if we find an opening pattern, or if we find a closing pattern, so this one, I think basically just needs to say, you know, while there's another thing to look at, if we find another opening pattern, then we consume it and we increment the nested count. If we find a closing pattern, then we say if nested count is greater than 0, then all we need to do is decrement the nested count. Indent for me, please. Please. Minus equals 1. Why was it not indenting? Is there some issue somewhere? There's the brackets are not handled properly. So this is for the regular single line comment. This is the multi-line comment. We have for, else if, else. I don't know why that would be an issue. Let's just continue with this logic. So if we have some nested, then we just decrement. Otherwise, God, that's annoying. Otherwise, it means that we break out of this loop, I think, because well, I guess, sorry, in this case, we also need to consume it. But here we need to break out of the loop. I guess in any case, In any case, we consume it, right? In any case, we've found this pattern, which is the closing pattern. And the question is, do we decrement? I guess we don't even need to break out, right? We don't even need to break out. Because we've consumed it. No, I think we do need to break out. Otherwise, it's just going to keep going. Break. Now we need to figure out what's going on with this. Something's gone wrong here. I've put a character in the wrong place, or so this is where we find the slash. Now we say this one. Well, I think we can just comment out this to see whether that's the issue. Doesn't look like it. So then we have if index plus 1 is less than source, and that's the character. Then we have these statements, they look fine. Then we say if index is less than the length of source, or while index is less than the length of source, we have this for loop. This is a simple if index plus 1. Oh, that's kind of consuming the closing, which we already take care of. Then we have if that's less than that, and and we're missing an and. That's probably what it was. Invalid token at line 70. Really? Line 70, column 35? That might be because, this is interesting. There could be, like, within here, we don't allow new lines, right? But within here, we do allow new lines, in which case we need to increment the line number and reset. So it's the same as up the top here, or maybe not quite that high. Yeah, this is when we process a new line, so we need to do this if we come across a new line. So we're doing multi-line. We're going through all these characters. Do we find these patterns of opening or close? No, we don't. So I think now we need to go else if it's a new line. Source index. If it's a new line, single quotes, is it? And then we do that kind of incrementing. Otherwise, we do the regular incrementing. I guess we need to do index plus 1, 2. Still says line 70, column 35, which feels pretty wrong to me. Let's see. If we take out this nested comment, is it still working? No, it's not. It's tokenization. So let's rationalize through this again. First we found a slash, then we found the second character as a star, so we go multi-line comment, slash star. We consume the slash and the star. And then for every character after that, we say, do we have this pattern? No. Do we have this pattern? No. Do we have a new line? Yes. So consume it and update these. That feels right to me. Let's have a look. Let's debug through it and see what happens. So we found the pattern. This should be sort of consuming that pattern, I think. We still have characters to go. It should not be that pattern. It should not be that pattern. But it is that pattern. Because we're doing not equals. To match the pattern, it should be equals. Come on. That's fine. Now when we do nested, it's also fine. How cool is that? Nested multi-line comments. Not bad for just like 10 minutes at the end of the video. Single line, multi-line, including nested multi-line. I just wanted to throw that in there because I thought, this episode is a bit of like a kind of, it's preparation for types, and I didn't feel like there was much of a payoff, so I thought it was nice to throw that in the end. Cool. All right, I'm happy with that. Next time we're going to actually implement the type checking, make sure that the types don't mix up. When it's expecting an I64, you have to give it an I64. And I guess we need to coerce some types. If we get this number, then we need to upgrade it to, in this case, we need to upgrade it to an I32 because that's what the Power32 is expecting. Yeah, so that should be challenging. But yeah, it should be fun. Okay, thanks for stopping by. Have a good one. Take it easy. I'll see you next time. Ciao for now.